All right, welcome back to Videos with Miss Leslie. Today we start our Unit 5, which is graphing trig functions. Today we're kind of introing the graphs for sine and cosine. We're going to look at the period of the different graphs, and we're going to talk about amplitude and vertical shifts. So here we go. Okay. So first off, we're going to use our unit circle values to sketch a graph of both sine and cosine. And then we're going to talk about some key parts to both of these two graphs. Okay, so first off, we'll do sine. All right, so remember your sine value is like the y value from your unit circle points. Okay, so at 0 degrees, sine is 0. At 90 degrees, sine is positive 1. At 180, sine is 0. At 270, sine is negative 1. And then at 360, sine is 0. All right, so if we go to our graph, all right, we have 0, 90. So these are our x-axis values, right? 180, 270, and 360 degrees. Okay, and then on our y-axis, we have positive 1 and negative 1. All right, now, if we continue, so like this is one rotation around the unit circle. If we were to continue going, all right, so say 360 and then go another 90 degrees and then do another 90 and so on and so forth, we would start to repeat these values. Right? You can already see it repeating a little bit from 0 to 360, right? Because we went one journey around the unit circle and we're back at that first point, that 0 or 360, right? We could just keep going, all right? The graph of sine does actually continue in both directions forever, all right, with these same kind of values. All right, one journey kind of around our unit circle, and when we graph it, you'll see it completes one full like shape, start to finish. That's what we call a period. All right. The period is how long it takes to complete one full rotation. Sine completes one full rotation every 2 pi. All right. So that's something that's important to remember. All right. So this right here is what we call one period, which equals either 2 pi or 180 degrees. Oh, 360, my bad. Ooh, 360 degrees. Okay. Okay, so let's go ahead and sketch this. So at 0, I have 0, 0. 90, I am up 1. 180, I'm back at 0. 270, I'm at negative 1, and 360, I'm back at 0. Connecting the dots, we have this nice, beautiful sine curve. And like I said, it does continue. So if I wanted to keep going, I could keep going that direction. I could keep going backwards if I wanted to. So sine does continue going in both directions. It's just going to keep repeating this up and down wave that we have right here. All right, but like I said, this right here is one period. One period. I'm writing in highlighter, so it's not like the best handwriting there, but I try my best. Right, so there we go. So we have one period. All right, so if you notice the sine function, when you graph it, it kind of looks like a sideways S, which is really nice, right? It helps us remember, like, if we graphed it right, it should kind of look like a sideways S. All right, moving over here to cosine. So now we're going to fill the values in for our cosine function. So at 0, cosine is 1. At pi over 2, cosine is 0. At pi, we have negative 1. 3 pi over 2 is 0, and 2 pi is 1. All right, so we've repeated our values. We started with 1. We went through all the values. We ended up back at 1. So again, just like with sine, this is one period, which is equal to 2 pi or 360. Okay, so it took us 360 degrees to get back to where we started. All right, now we're going to look at the graph for this. So we're going to do the same thing. We're going to write in our values. So we have 0, and we're in radians, so we'll graph in radians. So 0 pi we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. All right, our y-axis values are +1 and -1. All right, and so now we're going to plot these points. So at 0, we have 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is 0. And 2 pi is 1. So connecting our dots, remember this is a curve, not an absolute value graph. All right, we have this nice, beautiful cosine curve. And I always think of this, so just like sine, I said looks kind of like a sideways S. Cosine kind of looks like a sideways C, right? A little curvier than a C, but you could definitely make an argument that this is a sideways C. Now again, we could continue in both directions, right? We could add a little bit more. We could keep, because we are going to keep going, right? There's an arrow on this end. We're just going to keep going forever in this nice little cosine wave. Same thing over here, right? It would go backwards forever doing a cosine wave. So essentially, truthfully, right? If you were to extend both sine and cosine graphs forever, they look almost exactly the same. The only difference is they are crossing at different points, right? But they are essentially going to keep going up and down between 1 and -1 for forever. That's called, it's called an oscillating function. It oscillates, it bounces back and forth between two values. And yeah, so that's what our two graphs look like. So this is 1 period. So 1 period. All right. And again, a period is how long it takes. So period is how long it takes to complete one full sine or cosine wave, right? So like one full wave. So with sine, we have that S shape. Cosine, we have that kind of a C shape, right? Like that. Okay. And like I said, for both sine and cosine, the standard period is 2 pi or 360. Now, for all the ones we're going to do today, our period is going to stay the same. It's going to be that 2 pi or 360. We'll start changing that tomorrow, but for now, we're going to have like that nice standard 2 pi. Okay. Now we're going into our transformation rule. So that is our basic sine and cosine graph. So now we need to go into transformations because of course we're going to be transforming our two functions here. So I'm going to zoom in a little bit. That was zoom out, wasn't it? Brilliant. There we go. Okay, so there we have our two above. So our transformation rules. So these are your standard equations. Hold on, let me just move this a little bit. It was kind of blocking. There we go. Okay, so here are the standard setups for your sine and your cosine. All right, you notice there's a lot of letters in here. These letters we've been kind of dealing with the entire school year, and they actually do the same thing in our trig functions that they do in normal functions, like quadratic or square root or absolute value. So they do have some different names though, so we're going to go through them. So we have the A out front. That's what we call the amplitude. So A is our amplitude. All right, and the amplitude is the distance, all right, from the y-axis to our highest point, all right, and not necessarily always the x-axis, sorry. So amplitude is the distance from the x-axis, usually, well, we won't even say x-axis, we'll just say amplitude, the distance from, we'll say x-axis for right now, x-axis, distance from the x-axis to the max and min point of the graph. All right, so if you look at our two graphs that we have up here, all right, so our sine and our cosine graph. So here's our x-axis, right? So I'm on the sine graph, I just highlighted the x-axis. All right, the distance that we have right here between that x-axis and our highest point, that's what we call the amplitude. This is the amplitude. All right, and for the original sine function, there's an amplitude of 1. Now the distance above the x-axis and the distance below the x-axis should always be the same. All right, so if you look at the same sine graph, but you look at the 270 where we're going down 1, that is also the amplitude, and it should be the same, which it is, it's 1. All right, so your sine and your cosine graph are always going to be the same distance away from this center line, which brings us to our next point that we're going to talk about, which is the d value. So I know we're not going alphabetical here, but it's okay. All right, so the d value, this is our vertical shift, right? So it's shifting our graph up and down. So vertical shift. All right, so it moves our whole graph up and down, all right, by the same amount. Now, another important part about this vertical shift or this d value is that it moves that x-axis line. It moves that up and down. We call this the midline, all right? So the midline is the center of the graph. All right, so we're going to shift that up and down, all right, depending on whatever d is, right? If it's +1, we move that. The whole graph moves up 1, which changes where that kind of center line is, all right? So we call this center line the midline, all right? And the equation for the midline, so equation for midline is y equals the d value. All right, so whatever your d value is, y equals that is that horizontal line that we call the midline. So midline is y equals d. These are the two transformations that we're going to be looking at today. All right, the b and the c, those are horizontal transformations. All right, we're not going to be doing those today, but I will talk about them really briefly. All right, we're going to hit more on them in the next coming classes. But B is what we call the frequency. All right, so the B value is the frequency. Now, frequency means is basic. It's very similar to the period. So the period is how long it takes us to complete one full wave or one full cycle. The frequency is how many cycles happen between 0 and 2 pi. All right. Now, in a normal trig function, when you don't have any transformations, right? So if we were to scroll up to our original sine function, right? It's just sine of x. There's nothing next to the x. It's just a 1. So that tells us that the standard frequency is 1, which makes sense because if we want to know how many times we do a wave between 0 and 2 pi, the answer is 1 with a standard sine or cosine graph. All right, and we're going to talk more about that frequency piece next class. All right, so B is your frequency, okay? And then the last piece, which is, oh no, I don't have another highlighter color. It's okay, I'm gonna make one up. We'll just do this weird blue, this blue. Okay, the last piece is this C value, right? So hold on, A, B, what did oh, B, right, so there's B. Okay, so the C value is what we call the phase shift. All right, we would normally just call this the horizontal shift, and it's the same thing. It's shifting our starting point for our graph, left and right. All right, so the phase shift is, again, similar. It's a horizontal shift. It just has a fancy name called the phase shift. All right, but yeah, it's going to move our starting point. Again, we're not talking about these two today. We're going to talk about them later. We're not going to have any frequency or phase shift changes. These are what we're going to talk about though later on, later topics. Okay, so keeping in mind, we're going to save the B and the C value for later. All we're going to work on today is different changes to our amplitude and our vertical shifting. All right, so let's look at an example. Okay, so let's scroll a little bit. There we go. View, and let's just zoom in a little bit more. There we go. All right, now we can kind of see everything. All right, so it says determine the amplitude, vertical shift, the midline equation, and the range for the equation below, and then we want to graph it. All right, I'm going to make this a little bit bigger. There we go. Okay, so first off, let's just write that out. So amplitude. All right, and then it says vertical shift, midline, and then range. Okay, so our amplitude is that A value. So it's the number that is out front. All right, so for our problem, that's going to be 15. All right, and that means that when we graph our function, we're going to be 15 up and 15 below whatever that middle line of our equation is, whatever our midline is. Okay, moving on, we have our vertical shift. All right, and we are going -3 vertically, so we're shifting down 3. So down 3. All right, midline. So this is y equals whatever the d value is, right? So 15 is A, and then -3, that's our d value. So our midline is y equals -3. Okay, now for range, this is really easy to figure out. All right, so your middle of your graph is -3, right? Okay, so if -3 is our midline, right, and we have an amplitude of 15, so that means we're 15 away. So 15 this way, 15 this way. Oops, let me scroll down a little bit more. Okay, so because that's our amplitude, right? Amplitude is how far we are away from that center line. All right, so to find our range, we can just add 15 to find our max value and subtract 15 to find our minimum value, right? So for this one, our range is going to be from -18 to +12. Oops, that's a bad bracket. There we go. All right, so -3 minus 15 gives us the -18, and then -3 plus 15 gives us that +12. So that's the range of our function. So we're bouncing between -18 and 12. Okay, so let's go ahead and graph this. Now, I like graphing it with my midline always the center. So even though I know this is like, looks like the X and the Y axis, I always put my midline as the center line. So all I'm gonna do is just gonna label this as -3 because I want this line right here to be the center of my graph. All right, and then I'm going up to +12 and then I'm going down to -18. All right, and make sure the max and the min value are the same distance away from that midline when you're doing like your marks or whatever. Why is it -18 popping up? It'll get there. Okay, so that takes care of our amplitude and our vertical shift changes in our graph. So now we want to go through and want to label our x-axis with our points. These are the same exact points that we had in our original graphs. So we have 0. And does it say we're doing this in degrees or radians? It does not. So if it doesn't specify, it's up for you to pick, unless you see like, for tonight's homework, it really is just your choice unless it specifies. In the future problems, when we start to have like different periods or different horizontal shifting left and right, you'll know if it's degrees or radians because there'll be either a degree or a radian symbol in the problem. Since this one doesn't have that, we really can just choose whichever one we want. I'm going to do radians because that's the one that you guys generally like the least. So we got to get used to it. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now you don't have to plug in these numbers into your equation to figure them out. If you can remember the standard cosine and standard sine like pattern, it stays the same every time. So cosine starts up at its highest point, goes to 0, then it goes to the lowest point, then back to 0 and back to its highest point. It will always follow that pattern. All right. So at 0, I am at positive 1 or 12, right? My highest point. At pi over 2, I'm at 0. At pi, I'm at negative 18. At 3 pi over 2, I'm at 0. And at 2 pi, I'm at 12. So I've now completed one full period. I'm going to go ahead and connect my dots. Remember, this is not an absolute value graph. This is going to be a curve. Please don't draw absolute values. All right. And that is the graph of one period of my equation of cosine. Remember, it does go further this way and it does go further this way. So if you want to put the arrows on the graph, you can. All right. Just to know that it does continue in both directions for forever. All right, guys, that is it for our introduction to graphing sine and cosine. I hope it was helpful. If not, you can always come by during office hours and I can help you figure out anything else that you need to know. All right, until next time, bye guys.